All right, so what we're going to do today, just to get, I guess, back on track. We didn't meet last week because of the weather conditions. We met the very first day, all right, about a couple of weeks ago, and just taking a look at XYZ homework. I've taken a look at the homework, and it seems like everyone is up to like 1.4. Even though we have not had a physical class since the first day, um, there's this video lectures link just in case this happens again. And I kind of mentioned this on the first day, where in this video lectures link, all of the sections have been like pre-recorded, that sort of thing. So hopefully you've been viewing these. For module one, there's 4 videos that are like concerning all of the topics that are in module one. The main thing in module one is something called unit analysis, where we use a unit analysis to convert from one measurement to another measurement. So what I intend to do today is I passed out a module one review exam. So what we're going to do today, and I guess on Tuesday, we'll kind of review this exam. And as we're reviewing through this exam, we'll kind of go through all of these topics that are in module one. And then your test is going to be similar to this test. All right. So we're actually like going through the test. It seems like everyone's almost finished with the homework. All right. So with that being said, I passed out now I printed this up, so the print version is not too like reader friendly. There are actually, I believe, 16 problems are going to be on the test. And there's 16 problems on the test. On this review sheet, the very 2 last pages are actually the answer key. Right? So it doesn't really show you how to work them out. We're going to do that in class, but it gives you the solutions, kind of those last couple of pages. So what we're going to do today is basically just go through the exam. The exam is scheduled for, let me just get back into XYZ homework. It is scheduled for February the 4th, which is next Tuesday. So what's actually going to happen next Tuesday, you won't actually take the test in class. The test, all of the tests are going to be take-at-home tests. What we're going to do in class next week is we're going to finish this review just in case we don't finish it today. All right. As far as the exam is concerned, let me check the settings. Okay, there is no password. Okay, the exam is set for 2. I'm going to put 240 minutes, which is 4 hours on it. There's no password. It's open until February the 4th at midnight. If you take it out to February the 4th at midnight, there will be I think I got a penalty thing. There's like a 10% penalty. Okay. So next Tuesday in class, we won't have the test. We'll just kind of continue this test review. All right. All right. So with that being said, let's take a look at the review exam. All right, so I'm basically just going to go through the exam. Please feel free to write on this. Like I said, the answer key is on the very back. All right, so this first question, it comes out of the module 1.1, and we're asked to make the following U.S. system by multiplying by the appropriate conversion factor. Write your answer as a whole or a mixed number. Now, as far as the exam is concerned, this is one thing I've noticed. In some of the problems, they will give you the formulas to use. For example, in this first problem, they don't really give us any formulas. If you turn to problem number, I believe it starts at problem number 12. Notice that this is not real print friendly, but it gives you some of the conversions that you may need to answer the problems. So it looks like problems 12 through, I believe, 16, they kind of give us these formulas. I know they don't look too like appealing or whatever, but they give you the formulas. For the first few problems, not so much. In the module 1 set of homework notes, there is a formula sheet or a couple of formula sheets. One is the standard conversion. So I am going to bring this up. And I didn't quite print these off, but, and I'm also going to open up the metric conversions. And here we have the conversion chart. And this is the English unit of measurements. And on this, you can find conversions for liquid measures such as ounces to cup, that sort of thing. We can also find dry measure, pints to quarts and gallons. There's also linear measure, and linear measure is the distance. 12 inches is a foot, 3 feet is a yard, and there's some called furlongs. Right, 8 furlongs is 1 mile. 6,080 feet is 1 nautical mile. All right, so this has some formulas for standard units, and then the metric formula sheet has some formulas for the metric system. Okay. So while you're taking your test, I would suggest you use the English unit formula sheet, the standard unit formula sheet, you can also use Google. I mean, in my opinion, if you were asked to like solve a math problem, and if it was outside of any institution, you would probably just go to Google for like a whole, I know I do that. So there are also some conversions that are within Google that make this stuff a whole lot easier, at least up front. All right. So we're going to get to that in a second. All right. So let's take a look at the very first problem. Right. It says make the following conversions in the U.S. system 2 feet to inches. Now there's something called it can be called a couple of things. It's called dimensional analysis. You may hear it called a unit fraction. And we can use dimensional analysis, which is a unit fraction, to convert from one unit to the other. Now here's what a unit fraction is. A unit fraction is a special form of 1. Now, if you're talking about a fraction, if you put anything over itself, that equals to a 1, right? 12 over 12 is 1. 0.5 over 0.5 is 1. And if you look at your conversions, so if I bring up the standard unit of measure formula sheet, we can also make unit fractions, and we're going to start with this linear measure. It says that 12 inches is equal to 1 foot, right? So I can actually form a special kind of 1 between the 12 inches and 1 foot. Since they're both equal, I can put 12 inches over 1 foot. Since they're exactly the same, that's a special form of 1. I could also reverse that around. I could put 1 foot divided by 12 inches. Both of those things are a special form of 1. Right? Because you're putting the same thing over the top of itself. Question? I think I got it. You want us to write on it, right? Yeah, that's yours to keep. I have it's okay. All right, so anything over itself is a special form of 1. When you multiply anything by 1, you don't change the value, but you can change the way that your number is expressed. So here's how I'm going to use that unit fraction to convert 2 feet to inches. I'm going to take 2 feet and I'm going to multiply that by a unit fraction, right? That special form of 1. So I'm going to use the conversion 12 feet, 12 inches is 1 foot. However, I want to be careful on how I situate my units. Since I want my unit of feet to cancel, I'm going to put feet in the denominator. And since I want to convert from feet to inches, I'm going to put inches in the numerator. So now I'm going to write out my unit fraction. So when I write out my unit fraction, here again, it's a special form of 1. So I'm going to write out the conversions. 12 inches is equal to 1 foot. Right. So I have 2 feet times 12 inches divided by a foot. So now here's what happens. This 12 inches over 1 foot, that's a special form of 1, right? It's like a 1 in disguise. When I multiply, I'm going to have some units to cancel, right? So remember, from multiplication, whenever you multiply fractions, and I can express 2 feet as a fraction, I can put 2 feet over 1, right? So you can put anything over 1. When I multiply my fractions, I want to cross cancel if possible. So that means that this foot is going to cancel this foot in the denominator. So now I'm only left with the unit of inches is what we want. So now I'm just going to multiply. I'm going to multiply my numerators. 2 times 12. I'm just going to write that out. I'm going to multiply my denominators. 1 times 1. I'm going to keep my unit, which is now what? Inches. And now I'm going to simplify. 2 times 12 is 24. 24 divided by 1 is 24, right? And I'm going to keep my unit of inches. So 2 feet is equal to 24 inches, right, by using a unit fraction. You can also use Google. So in the search, I'm going to put inches to feet. In the search, I'm going to hit enter, and then it's just going to give you, this is just so nice, it just gives you the conversions already laid out. I could put in 2 feet, excuse me, I can put in 2 feet, just make sure you're using the right conversion. So 2 feet is going to equal 24 inches. So that's using this conversion window. I'm going to let this stay up, because if you click in the drop down arrows, they give you more than just one option. So over here, I can convert from kilometers or whatever I want to convert to, as long as it's within these drop downs. Right, so there's a mathematical way to do the problem, by using the unit fraction, right? And then there is the conversion in Google. All right, problem number 2. It says make the following conversion in the U.S. system by multiplying by the appropriate conversion factor. Write out your answer as a whole number or mixed number. Now you have to be careful with the directions, because if we were to answer this as a decimal, it would mark it incorrect. You have to answer it as either a whole number or a mixed number. So let's look at number 2. And I believe they do this because if you're using Google, it's only going to give you the decimal, not the fraction. All right, but we're going to work around that. So here we're asked to convert 9.25 miles to feet. So I'm going to start with 9.25 miles. I'm going to multiply 9.25 miles by a unit fraction. Since we're trying to convert miles to feet, I'm going to put miles in the denominator and feet in the numerator. And be careful on how you situate your units, because remember, you can only cross cancel units. So since I want my miles to cancel, I'm putting miles in the denominator of my unit fraction. I'm putting feet in the numerator. So now I'm going to write out my unit fraction. So I'm going to look back at my formula sheet, and I want to find the conversion from feet to miles. So it says that 1 mile is 5,280 feet. So 1 mile is 5,280 feet, right? So that's my special form of 1, right? Anything over itself is 1. So now that I have my unit fraction set up, I'm going to cross cancel. So the unit of miles cancel. And now I'm going to multiply 9.25 times 5,280. We have 48,840 feet. I mean, so not too hard to do it mathematically, but you must know the conversions. I'm going to pull up Google, and let's see if there is a mile in here. So over here, I'm going to put mile. Over here, I'm going to put foot. And I'm going to put in 9.25 miles. And it gives us 48,840 feet. The exact same as with the hand calculation. All right, any questions about the first couple rounds? All right, for the next problem, problem number 3, it says make the following conversion in the metric system by multiplying the appropriate conversion factor. Write your answer as a whole number or decimal. Now, as far as the metric system is concerned, there is a conversion chart. Metric system conversion chart. So here's a little slogan. It says that King Henry died by drinking chocolate milk. Anybody ever heard of this? Okay. So now this is what's called a mnemonic device, and it helps to remember the order for the metric system. So the King Henry died by drinking chocolate milk. Here's what it alludes to. The K is for kilo, and kilo is a unit of measure for the metric system. The H is for hecto. The D in died is for deca. The B is for what's called the base unit. So there's 3 base units in the metric system. If you're measuring weight, weight is measured in grams, which has the symbol G. If you're talking about length, length is measured in meters, and the mathematical symbol for meters is M. And then if you're talking about capacity, capacity is like the amount of liquid something can hold. You're talking about liters. So for example, when you drink a liter soda, liter is a metric system of measurement for volume or capacity. The D is for deci. The C in chocolate is for centi. And the M in milk is for milli. So King Henry died by drinking chocolate milk. And you can add to that. One is mighty King Henry died by drinking chocolate milk while munching nuts. So M is like for mega. It goes all up and down the scale. But for our purposes, we're just going to use King Henry died by drinking chocolate milk. You use this chart, and it gives you the direction and how many places to move your decimal. So let's see how this chart works. All right. So in my problem, we're asked to convert 17 dm. So dm is for decimeter, and we want to convert that to centimeters. 17 decimeters to centimeters. All right. So what I'm going to do is I'm going to find where 17 decimeters would lie in this chart. So let me just separate this out a little bit. And this is deci. Okay. So there's grams, meters, and liters. So 17 decimeters is going to be right here, right? So this is 17 decimeters. If I want to move from decimeters to centimeters, that means that I would have to move one place to the right. So in 17, the decimal is behind 7. So if I move that decimal one place to the right, 17 decimeters should equal to 170 centimeters. So it's just a matter of placing your number in this metric system chart and moving your decimal accordingly to what you're trying to convert your unit to. So the answer for this one, 17 decimeters is 170 centimeters. You could also use Google. Right. So in the search, I'm going to put DM to CM, decimeters to centimeters. And I'm going to hit enter, and it gives us this same little chart. So I can put in 17 decimeters. Oops. And it should spit out 170 centimeters. All right, so moving right along, number 4. It says it's a horse racing example. In horse racing, 1 furlong is equal to 220 yards. How many feet are in 10 furlongs? So here it kind of gives us a conversion. It says 1 furlong is 220 yards. How many feet are in 10 furlongs? So for this one, I'm going to use a couple of conversions. Since they give me this fact, 1 furlong is equal to 220 yards, I don't want to go searching for a formula sheet because that formula sheet might not give me the same exact conversion. Well, now here's the thing. It says 1 furlong is 220 yards, but we want to convert 10 furlongs to feet. So I'm going to have to make 2 conversions. So this is how this is going to work. So we have 10 furlongs, right? For my first conversion, since they give me this conversion, it says 1 furlong equals to 220 yards. When I set up my first unit fraction, I'm going to put furlongs in the denominator, and I'm going to put yards in the numerator. And I'm going to write out my unit fraction. 1 furlong is 220 yards. So that means when I multiply, the furlongs units are going to cancel, and I'm left with yards, right? But I don't want the answer in yards. We want the answer in what? Feet. So I'm going to have to make another unit fraction. And in this unit fraction, I'm going to put yards in the denominator. And I'm going to put feet in the numerator. So now if I write out this conversion, 3 yards is equal to 1 foot. Now I can actually find this conversion on the one of those charts. This is a common conversion. If I go back to the English measurements, right, 1 yard is 3 feet. So when I wrote out that unit fraction, I put yards in the denominator because when we cross cancel, the yards are going to cancel. And now I'm left with only feet. I'm just making sure y'all paying attention. Okay. You're exactly right. 1 yard is 3 feet. Thank you for clearing that up. I'm just making sure y'all paying attention. So, all right. All right. So now that we have the right conversions, the unit is now in feet, right? So now I can just multiply all my numerators. So remember, we can put that 10 furlongs over 1. So if I multiply the top 10 times 220 times 3, right? So we should have yeah, 10 times 220 times 3. I'm just looking at this answer key. $6,600, and I'm looking at this answer key to make sure it's right. For number 6, not for number 4. Okay, yeah, 6,660. I'm just making sure this answer key is right. All right, so that's 6,660 feet. So now I'm going to try the Google thing. I didn't try this one with Google. So I'm going to go into the search furlongs to feet. So we want 10 furlongs. All right. So, and this is what I was saying. Notice when I put this in Google, I got 6,600.01. But when we worked it out by hand, using the measurement that they gave us, we got 6,660 feet even. So take that with a grain of salt, because Google, they were probably not using this formula for furlongs. It might be slightly different.
Okay, so what if you did half of it? Like if you did the 10 and the 220, and then you did, like you got your answer from that, and then you just converted
to feet. That should work. Let me try it. Let me try that. You talk about in the Google thing, right?
Yeah.
Okay, let me just try that.
From your yard.
I got you. So we're going to go from furlongs to yards.
What is a furlong?
A furlong, that's using horse racing. I had to look that up myself. Like, what is it? I've never heard of that, but it had something to do with horse racing. So, like, the equestrian stuff, and I'm from Augusta. I am not from Aiken. I don't know anything about it. But I do know that they got the equestrian horse trails, all that horse stuff. They use furlongs instead of feet and whatever. Yeah, they have like the equestrian with the horses. Yeah.
It's like once a year, people just come through and it's a big old horse.
You see horse stables and.
It's really,
like
everybody here, they take it as a drink. It's not, they don't take it for serious.
Right. So let me try that. So I'm going to go into Google and I'm going to put furlongs to yards. So 10 furlongs is 2,200 yards. And now I'm going to convert yards to feet. What was it, 2,000? And I get it exactly. All right. And sometimes you might have to finesse them a little bit, but notice when I put strictly from furlongs to feet, I got like a little fudge factor at the end. All right, so that was number 4. So we had to use 2 unit fractions or 2 conversions. Number 5 is the same. It says track and field. A person who runs a 100-yard dash in 10.7 seconds, is that fast or slow, has an average speed of 9.35 yards a second. I think that's pretty fast. You can run 9 yards in a second. You flying. Right. Okay, so let's just take it one at a time. So like a 100-yard dash, 100 yards would be the length of a football field, right? So this says a person can run a football field in 10.7 seconds. So if he starts at the 0-yard line, run 0.7 seconds later, he should be at the other end of the football field. And it says that that person has an average speed of 9.35 yards per second. So that means that in 1 second, that person is running 9.35 yards, which is about 27 feet. Whoever's running that is moving. Got to be in the NFL, right? So what they're doing is they're giving us the speed that that person is running that 100-yard dash. We have to convert 9.35 yards per second to miles per hour. So this 9.35 yards per second, right? That's how I'm going to write that out. So we have to do two conversions. We have to convert yards to miles, and then we got to convert seconds to hours. Okay. So does everybody see where we're going? Because my final answer has to be in miles per hour. So the first thing I'm going to do is I'm going to rewrite yards as miles. So since I want yards to cancel and yards is in the numerator, I'm going to put yards in the denominator and I'm going to put miles in the numerator. So I'm going to find the conversion from miles to yards. So I'm going to go back into the formula sheets. So it's like I don't quite see a yards to miles. I can convert from like miles to feet, and then I can convert the feet to yards. Or I guess I can do that as a separate calculation. So this is what I'm saying by that. Well, I guess I'm going to do it that way. I'm going to convert from yard to feet, and then I'm going to convert from feet to mile. Everybody see how that's kind of working out? So like 1 yard is 3 feet. So that means that this unit of yard is going to cancel. And then 5,280 feet is equal to 1 mile. So my unit of feet will cancel. Is everybody okay with it? I know that's two conversions because we couldn't go straight from one to the other. So we had to make like an intermediate conversion. So now I want to convert seconds to hours. Right. So since seconds is in the denominator, in order to cancel it out, I'm going to put seconds in the numerator. And I'm going to put hours in the denominator.
Quick question. Before you do that, if you wanted to, could you clean up all of that before you did that second hours?
You can simplify this. Yeah, you can go ahead and simplify that. Okay. And then that'll just give you miles, and then you can convert the seconds to hours. All right, so let me just clean this up a little bit. So what is our conversion? So if I go back to the chart,
Seconds to hours, right?
yeah, is that on here? Or how many seconds in an hour?
Yeah, 3,600.
3,600, right? So just to verify that, I'm going to go here, and I'm going to put seconds to hours conversion. So
So when you do 60 times 60, right? Because there's 60 minutes in an hour.
it's 60 minutes in an hour, so it should be 3,600. I thought that was written out somewhere in one of these formula sheets. Let me just make sure. Yeah, so 1 second. I guess since that's, a common one, I don't actually see it on here, but 1 second should be, or 1 hour, where am I? 1 hour is 3,600 seconds, right? So now the seconds are going to cancel, and I'm left with my miles per hour. Right. So now we're going to multiply the numerators, multiply the denominators, and then divide last. So this is 9.35 times 3 times 3,600, which is 100,980, divided by 5,280. And then I have miles per hour. So now if I divide 100,980 divided by 5,280, we get, is that 5,280? Let me do that again. Yeah, I did something wrong. 100,980 divided by 5,200.
Oh, yeah, the 5. Yeah, the 5.
I added 5. Okay. Okay, and we get 19.125 miles per hour. I don't know if you can do that in Google. Let me see if it'll let you do. So now this is what I'm going to put in the search. I'm going to put in, what was it? Yards per second, YDS/seconds to miles per hour, and it like popped up right here. So it was 9.35, and we get 19.125. So I just put in yards/seconds, and then I just chose the first one, and it just gave me that conversion. All right, any questions about number 5? We had to make 2 conversions. No. 1, 2, 3. We had to make 3 conversions. All right, number 6. It says make the following conversion: 50 square yards to feet. Square yards to feet. So let me see if I've been trying to update these formula sheets. Square yards to feet. And I don't see square yards to feet. So this is how this is going to break down. So just notice in this, the problems prior, the units have not been raised to any power. Like in the previous problem, we looked at yards and seconds, and then before that, we looked at furlongs and feet. We didn't see any square feet or square yards. If your unit of measurement is squared, that square unit of measurement represents area. So for example, if you wanted to find how much fence to put in your yard, that would be a linear distance, right? You would find the length for the width, and you would find the length for the length, and you just add all of that up together, right? When you're finding square units measure surface of area. So the units alone, so when I say unit alone, that's like feet, yards, miles. Oops. So for example, let's just say this is a garden, and on a garden, like this is 10 feet, this is like 3 feet, this is 10 feet, this is 3 feet. So if you wanted to find out how much fence you need, you would just add 10 plus 10 plus 3 plus 3. So you would need 26 feet of fence, right? If you're talking about areas in square units, the area measures the amount of surface something has. So let's say this is 10 feet, this is 3 feet, this is 10 feet, and 3 feet. So let's say you want to put carpet in your house, and you measure your living room or whatever, and it's 10 feet by 3 feet. If you want to go and buy some carpet, you wouldn't say I want 26 feet of carpet, because carpet measures square units, and square units is the amount of surface. So in order to find the amount of surface, that's the area. So I'm going to multiply 10 feet times 3 feet, and you get 30 square feet. So if you want to go buy some carpet, you would say, I need 30 square feet of carpet. So they're going to cut you a piece of carpet that's like 10 by 3. If you go to Lowe's and say, I want 26 feet of fence, they're going to give you 26 feet of fence. All right. So if it's just the unit alone, that measures the distance around the object. But if it's a square measurement, that's the surface area of an object. So now here's how these conversions are come about. So let's just say that this is 3 feet and this is 3 feet, right? So how many square feet would this be? 9 square feet, right? How many 3 feet is how many yards? 1, right? So 3 feet is 1 yard. How many square yards would this be? Well, I'm multiplying. So 1 times 1 is 1 square yard. So this is actually the conversion you're going to use. 9 square feet is equal to 1 square yard. Based on this little diagram, right? Because 3 feet is equal to 1 yard. And if you're dealing with a square, 3 feet times 3 feet is 9 square feet. 1 yard times 1 yard is 1 square yard. So this is the conversion I'm going to use for my unit fraction. So now if I go back to the problem, I have 50 square yards, and I want to convert square yards to square feet. And we just found that conversion, right? 1 square yard is 9 square feet. So now if I multiply, my yards are going to cancel. 50 times 9 is 450 square feet. So my solution should be 450 square feet. Now I'm also going to pop it in Google just to see what Google has to say. So I'm going to pull up the search bar. Now, normally when you put a power in, you have to use something called a caret. So I'm going to put in yards. And this is the, and if you look above the 6 on your keyboard, and if you hit shift, that gives you the exponent. So what that means is this is like square yards to square feet. So now I can put this in as, what was the problem? 50 square yards. So I'm going to put in 50 square yards, and it gives us 450 square feet. So you got to use that little caret. That's called a caret for the exponent. Okay. Might be another way to put it in, but
I think if you write all the way out,
what, square, write the word square out? Let's see. Yards. Okay, yards squared to feet squared. That is another way to do it. Yeah. Yep, that's another way to do it. All right. Okay, let's look at number 7. All right, so number 7 is a landscaping example, and it says a landscaper is putting in a brick patio. The area of the patio is 60 square meters, and this is where you got to be careful. We're given 60 square meters. If the bricks measure 15 centimeters by 20 centimeters, how many bricks will it take to make the patio? They're giving us 2 sets of measurements. The area of the patio is in square meters. They're giving us the dimensions of the bricks in centimeters. So what we're going to have to do is convert everything to square centimeters, and then we're going to have to divide. So here's what I mean. If a brick measures 15 centimeters by 20 centimeters, and here I want to find the area of each brick. So 15 centimeters times 20 centimeters. Well, 15 times 20, if I multiply it up, I believe that should give us 300. When you multiply centimeter times centimeter, you get square centimeters. Is everybody okay with it? Because coming from algebra, whenever you multiply like bases, you have to add your exponents. So this is like a centimeter to the first. That's like a centimeter to the first. So I keep my centimeter and I add my exponents. So you must square that unit of centimeters. So is everybody okay with the 300 square centimeters? So now this is what we need to do. We need to, the second thing we need to do is convert 300 square centimeters to square meters. Right? Because the area of the patio is in square meters, so we got to put everything in the same unit. So 300 square centimeters, we're going to convert that to square meters. So I'm going to look for the conversion. Square meters. And I wish this was one of the problems where they put the conversion formula in there. So this, I'm just going to use Google on this one. I'm going to convert centimeter square to meter square. All right, so that's my first option. And 1 square centimeter is equal to 0.0001 square meters. So 1 square centimeter is equal to 0.00, is it 3 zeros? Yeah. 01. So then my centimeter square is going to cancel. And if I multiply 300 times 0.0001, we get 0.03 square meters. So the area of a brick is going to be 0.03 square meters. So now what we got to do, the last thing is we want to divide, because I have to find out how many of these 0.03 meter square bricks can be divided into 60 square meters. So I'm going to divide 60 square meters, right? That is the area of our patio. I'm going to divide that by 0.03 centimeters square, which is the area of a brick, right? So we want to, oh, meters, that's right. We did change the unit. So if you divide 60 divided by 0.03, it should take 2,000 bricks. And this is probably about the most involved problem on the test, because the first thing is it gives you different units of measurement. So the first thing we had to do is find out the area of each brick in square meters, right? So we multiply 15 centimeters times 20 centimeters. We got 300 square centimeters. We converted the 300 square centimeters to 0.03 square meters, and then we divided. So it should take about 2,000 bricks to brick the patio. All right, so on the answer key, it does say 2,000. Now, as far as Google is concerned, I guess you would still have to make some kind of conversion, but let me just see if this will work. 60 square centimeters or square meters. So it'll convert 300 square meters to 0.03 square meters. But then you'll have to go back and divide 60 by 0.03 to get that 2,000 brick answer. All right. So I believe the only thing you can do here is just convert the square centimeters to square meters. All right. But the brunt of this problem is done by these hand calculations. All right. Let's take a look at number 8. We'll kind of do half today and then we'll do half next. So number 8 says make the following conversion: 673 milliliters to liters. Let's see. So we have 673 milliliters. So if I go back to my chart, 673 milliliters would be here. We want to convert milliliters to liters. So that means we have to move the decimal 1, 2, 3 places, right? Because our base unit is liter. So if I move my decimal 3 places, so for 673, the decimal is behind the 3, right? So I move it 1, 2, 3 places. So I should have 0.673 liters. 0.673 liters.